So on this screen you see a visual interpretation of what the problem gave you. There's a neutral rod, a charged metal sphere, you touch them together, bring them away, and then in the end the originally neutral rod repels the negatively charged piece of tape, which means that the neutral rod now has some charge. So the first thing I did to solve this problem was to figure out which charge the metal rod now has. Since opposites attract and similar charges repel each other, we know that the rod is negatively charged at number 4. So from there, if the rod is neutrally charged in the beginning and is negatively charged at the end, there must have been some sort of transfer of charges from the metal sphere to the rod, which means that the rod is a conductor. It's no longer some unknown material. We know it's a conductor. And the rod starts out neutral and steals negative electrons from the charged metal sphere. So the first statement is the rod is a conductor, true or false? I just explained that in the first part. The rod is a conductor because it gained some charge. The second one is the rod has a net positive charge after touching the metal sphere. Now, that isn't true because we already figured out in order for the rod to repel the negatively charged tape, the rod must have a net negative charge, not a net positive charge. So the second statement is false. The third statement says the magnitude of the charge on the metal ball is lower after the rod touches it. This statement is true because the rod was originally neutrally charged and has a negative net charge at the end, and the metal sphere was charged. So the rod stole electrons from the metal sphere, so the electrons were gained. There was a gain in electrons on the rod and a loss of electrons on the metal sphere. So the magnitude of the charge on the metal sphere is lower. The fourth statement is electrons flowed from the metal sphere to the rod while they were in contact, and this is true. We've kind of explained this to death. So the answer to the first part is the first statement, the rod is a conductor, is true. The second statement is false, the third statement is true, and the fourth statement is true. The second diagram shows basically that you touch the rod and then the charged tape is no longer repelled by any part of the rod. The hand virtually neutralizes the rod and makes it so that the rod is again neutral. If the rod started out negative before you touched it and became neutral after you touched it, then there has to be a transfer of positive atoms, in this case sodium ions from the salt water on your skin, because your skin acts as a conductor from the sweat. So sodium ions have to have moved onto the rod in order to give it that neutral charge. So statement 1 says, while touching the rod, chloride ions from the salt water on your skin moved onto the rod. No, that's false, because if chloride ions moved from the salt water on your skin to the rod, then the rod would become even more negatively charged, and that's not what happened. The second statement, while touching the rod, sodium ions from the salt water on your skin moved onto the rod. Yay, that's true. And we just explained that before. The third statement is electrons from the mobile electron C in your hand move onto the rod. No, that's false. The electron C makes things conductors, but even though the electrons are moving around, they are still bound to what other object that it's part of. So it's more difficult to get rid of them, as opposed to macroparticles like chloride or sodium ions. Electrons from the mobile electron C on the rod move onto the mobile electron C in your hand. Again, that's the same explanation as before. Protons are pulled out of the nuclei of atoms in your hand and moved onto the rod. No, you never pull out the nuclei of atoms, because that would be nuclear fusion, and that's just crazy. That would take way too much effort. So that's false, and protons are pulled out of the nuclei of atoms in the rod and moved onto your hand. Again, that's false. You don't pull the nuclei of atoms out just to change charges.